Hello everyone. So welcome to the second video in the playlist on superposition theorem. So I am doing a series of problems on superposition theorem. So for example, this is going to be the next video, this is going to be the next video, and so on. So in that previously I have done this problem. So now in the second video I am doing this problem on superposition theorem. So if you are already aware of superposition theorem and you want to try, you can pause the video now, look at the question, and you can attempt to solve this and compare your answers with my answers. Otherwise, if you are seeing this for the first time, so then you can try to understand how to solve this problem from this video, and then we'll go forward. Okay, so in this circuit, the question is to find the current I, and the I current is marked here with an arrow going from right to left. So there are three sources, so two current sources and one voltage source is there. Okay, so there are three sources. So let us use the superposition theorem. So what does the superposition theorem says? We have to consider one source at a time and try to calculate the current whatever we require, and then in the end we add all three. Okay, so let us consider the first 10 volt source. Okay, so consider 10 volt source. So when you are considering this source, all the other voltage sources should be short circuited and all the other current sources should be open circuited. So here you see we have a current source. Okay, so this side is 120 amperes current source and this side is a 40 ampere current source. Okay, so these sources we need to open circuit. Okay, so then the current becomes like this, the circuit becomes like this. So this is your I1, okay, and this is 10 volt, this is 150 ohms, and this is 50 ohms. Okay, so the other two, this side is open circuited and this side is open circuited, so it doesn't count. So only this circuit we have. So these 50 and 150 will be in parallel. So total resistance is 200 ohms and total voltage is 10 volts. So I1 is V by R. So 10 by 200. So that is nothing but 0.05, I believe. So let's just confirm. 10 divided by 200. 0.05 amperes. Okay, so this is the first current, and it is positive because we are in the same direction as it is concerned. Now let us do the next this one. So consider 120 amperes source. So now we have a current source. Okay, so that is 120 amperes. So look at this circuit. So this current source will remain and this voltage source will become short circuited, and this 40 amperes will become open circuited. So we have a resultant circuit something like this. So 120 amperes here, and then we have 50 ohms here, and then this is short circuited and this is 150 ohms. Okay, now the current I2, actually I will still continue in the same direction and then call it I2. Okay, so here it is open circuited. So it is a simple 120 amperes current going this way, dividing into two branches. So I can find I2 using the current division principle. And because our actual current will go in the opposite direction, because this current is coming downwards, so whatever value we calculate I2, that will be negative. So indicating that it is in the opposite direction. So I2 is minus of 120 multiplied by current division principle in a two parallel branches. So opposite branch is 50 and then 50 plus 150. Okay, so this is the current calculation. So when current goes through two parallel branches, the current in one of the branch is nothing but total current multiplied by the opposite branch divided by the total resistance. Okay. So what is this one? So let's calculate that. 120 multiplied by 50 divided by 200. So I'm getting 30 amperes. Okay. So actually compared to this 0.05, this 30 is quite high, so we should have I mean the problem, maybe this should have been 100 volts, at least it would have been 0.5, but anyway, so let's not worry about that, we will still consider that. So now we got I2. Now this is minus 30, by the way, so that means it is in the opposite direction. Now let's consider the 40 ampere source. Okay, so this is a 40 ampere source, let's consider that. Okay. So when we consider 40 ampere source, the circuit becomes like this. So this side it is open, so I'll get 50 ohms. The resistance, the voltage source is short circuited. I get 150 ohms, and let's call this current as I3, and then this side I have a 40 ampere. So here the current is 40 amperes. Okay. So this 40 ampere current again divides into two branches. So again I will get I3 is equal to 40. So this will be positive only because it will be in the same direction. So multiplied by opposite resistance 150 divided by total resistance 50 plus 150. Okay, so let's see what we get here. So 40 into 50 divided by 200. So I'm getting 10 amperes. Okay. So finally, to find the total current, I just have to say total current I is nothing but I1 plus I2 plus I3. So that is nothing but 0.05 plus minus 30 plus 10. Okay. So that is equal to 0.05 minus 30 plus 10. So minus 19.95 amperes. So this is the final answer for this particular problem, where you have to find the current I using superposition theorem. Yeah, I'm sorry, I made a calculation mistake here. 40 into 150 by 200 is actually 30 again. Okay, so this is 30. So this will be 30, and these two will cancel out each other, and finally the answer will be 0.05 amperes. Okay, so just make this correction. So there was a simple calculation mistake here. So because I was just verifying my answer and then was doing so what is happening is these two current sources are basically cancelling out each other. So the only current that is remaining is this one. Okay, so sorry for the confusion. Now there is another way. Okay, so a current source in parallel with resistance can be replaced by a voltage source of value I into R in series with same resistance. Okay, so this is a simple replacement. So see what I will do. I'll just, so that you can see both the circuits. See, there is a 120 ampere and 50 ohms, right? So these two can be replaced. A current source in parallel with a resistor can be replaced with a voltage source in series with a resistance. Okay, so this will be 6000 volts. Okay, why 6000 volts? Because 120 into 50 is 6000, okay, and 50 ohms. This is the replacement of the left side part of the network, and on the right side part of the network we have another replacement. Okay, what is 40 into 150? Again it happens to be 6000, so 6000 volts, and then 40 ohms is the resistance. So this is on the right side part of the network. Now these two can be mixed, and here we have a 10 volts supply. So here what is happening, these two, if I take, it's a single loop, these two will cancel out each other, and then I have a 10 volts battery supplying, this is 150 ohms. So 150 plus 50, 200 ohms. Okay, so current is nothing but V by R. So 10 by 50 plus 150. So that also I will get 0.05 amperes. Okay, this is another way of solving it. But here, since you are asked to solve it using superposition theorem, this is the way. And actually I just randomly selected these values, but then it turns out to be 120 into 50 is equal to 150 into 40. So this thing came up. So because of that reason, these two terms cancelled each other. Otherwise there would have been some current from one of these sources. But anyway, this still is a valid problem, and I made a small mistake. Sorry for the confusion. But this is the about the second problem. Okay. So let's continue with the this series. I'll do one more problem on superposition. In fact, more problems on superposition theorems in the later videos. Thank you.